Hi everyone, welcome to today's tutorial. So in this tutorial we're going to discuss how you can find the critical numbers and the point of inflection if it exists on a given function, and also to find the open interval on which the function is either increasing or decreasing. And we're also going to apply the first derivative, the first derivative test, to identify the relative extrema. Alright, so if you have not yet subscribed to the channel, make sure that you click on the subscription button, and also don't forget to click on the notification button so that you don't miss out the videos that I'm going to be posting on the channel. And then if you have any questions or you need tuitions, make sure that you contact me on any of these lines on the screen. Okay, so let's quickly begin. So the question says, consider the function f of x. Consider the function f of x is equal to half x to the power 4, then plus 2x cubed. And then the first question is find the critical numbers and points of inflection of f, if any. Alright, so the first thing that you have to do when you're finding the critical numbers is simply differentiating the function, because we know to say at either maximum or the minimum, or at the critical point, the value of dy dx, or the gradient function, is equal to 0, or rather the gradient is equal to 0. So when you differentiate any function, the answer that you get is called the gradient function. So the gradient function should be equated to 0 at maximum or minimum. And the other thing you need to understand is that the gradient increases. Okay, let me first explain the first point and then I'll come to the second point when solving it. Alright, so I was talking about the gradient being equal to 0 at the critical numbers. Okay, so let us quickly solve this question. Let us find the gradient function. So f prime of x is called the gradient function. So finding the gradient of this, finding the derivative of this function, we're going to use the power rule. So 4 times half here is just the same as 4 over 2, and then x, 4 minus 1, you're getting 3. Then we have plus, we have 2 times 3 there, we're getting 6, x, 3 minus 1, we're getting 2. So you divide this, we're going to get f prime of x being equal to, so f prime of x is going to be equal to 2x to the power 3 plus 6x squared. Alright, so this is the gradient function. So this is the gradient function. Let us now equate this to 0 so that we find the critical numbers. So we have 2x to the power 3 plus 6x squared is equal to 0. That is at the maximum or the minimum. Okay, so what we do is we solve this equation. And how do you solve this equation? We can factorize x, the common factors in this expression. So we know that 2 can go into 2 and also into 6. X can also go into this expression, x squared in this first term and also in the other term. So we're going to have 2x squared being common, and then here you're going to remain with x when you factor out 2x squared, and then on this part we're just going to remain with 3. Then this will be equal to 0. So either 2x squared will be equal to 0, or x plus 3 will be equal to 0. So when you find the solution for the first part here, you discover that the value of x will simply just be equal to 0, and then this other side you have x is equal to negative 3. So these are called critical points. Okay, so the point of inflection occurs the point of inflection occurs in this function. The reason is, there are so many reasons you can give, but according to me, I would say it occurs because the second derivative at one of these points is going to give you 0. Okay, so let us try to find the second derivative. So when you find f prime prime of x, you're going to get, so in other words, we're differentiating this the second time. So having 6x squared plus, this will give us 12x. So when you try to put 0 in this expression, okay, sorry for that. When you try to put 0 in this expression, you discover that the solution that you're going to get, f prime prime of 0, will give you what? Will give you 0. Then if you put negative 3 here, try to put negative 3, you're going to get, this will be 20, this will be 9 times 6. Okay, so 9 times 6 will give you 54, and then you also have negative 3. When you put negative 3 there, this will get, you're going to get negative 36. So when you add 54 and negative 36, you're going to get 18 as a solution. So at this point we don't have the point of inflection. The point of inflection occurs at this point. The reason why I'm saying when the second derivative is giving you 0, then it's a point of inflection, because we know to say if the second derivative of any given point on a function is if it's greater than 0, then it has a minimum value, then that function has a minimum value. Then if the second derivative of a function is less than 0, then it has a maximum value. So if it's less than 0, then it has a maximum value. And then if the second derivative is equal to 0 at that given point of a function, then it has the point of inflection. Yeah. So this is exactly how you're supposed to solve the first part. So these are the critical numbers they were looking for, and it has a point of inflection at x is equal to 0. Okay. Let's move on to the next one. So we have the critical numbers 0 and negative 3. So I'll write them here. So we have x is equal to 0 and x is equal to negative 3. And the point of inflection occurs at x is equal to 0. So let's move on to the next question. Find the open intervals on which the function is increasing or decreasing. So this one is also straightforward. How do you find that? We know to say a function is increasing only if the gradient is greater than 0. So when the gradient m is greater than 0, this tells us to say the function is increasing. And then at the stationary point, the gradient is equal to 0. And then when it is decreasing, the gradient is usually less than 0. So in terms of m as the gradient, this is what it means. Then in terms of dy dx or f prime of x, we say f prime of x is greater than 0 when it is increasing, and then at minimum or maximum f prime of x is equal to 0, and then when it is decreasing, f prime of x is less than 0. So this part is for the increasing part, and then this one for stationary point, meaning at maximum, minimum, or point of inflection. And then this other part, it's for the decreasing part, decreasing function. I mean decreasing side of a curve or a function. Okay, so these are the most important things you need to note on this question. So now, how do you find the open interval? This is one of the simplest questions. So the same gradient function that we found, the gradient function we found was f of x is f prime of x is equal to, we found something like 2x cubed. I think it was 2x cubed. When you differentiate this, you're going to get 2x cubed and then plus 6x squared. This is what we found. So now we're going to say at the increasing, or for increasing, if we start with the increasing part. So if we start with the increasing part, I'm going to get when the function is increasing, I know to say this this function should be greater than 0 on the increasing part of the of this function. So this gradient function should be greater than 0. So what you do is you find the critical numbers of this function, which we did. We found these two, and then after finding those two, you now test them in this expression. So we're going to draw a simple number line, and then I'll put my critical numbers. So I'll have 0 there, and then I'm also going to have, oh, it's supposed to be -3. So let me do this. So we have -3, and then we have 0. So all these numbers this side are numbers ranging from -infinity to 3. Then in between here we have numbers from -3 to 0. Then this side we have numbers from 0 to positive infinity. So now we can test these points. We see which part will give us or make this statement here correct. So how do we do that now? So let us try to get any number that is we try to get any number that is less than -3, meaning we're testing this part here, this part. So we try to get any number that is less than -3. So a number that is less than -3, we can even get -4. So if you put -4 there, you're going to have so if you put -4 where there is x, so if you put -4 where there is x, you're going to have -4 to the power 3. You're going to have okay, I think here I think when we leave it in this format, it might take us time for us to to solve the expression. But anyway, we can also use this same expression, but I like it when you factorize it. So when you factorize this, you're going to have 2x squared open brackets, and then here you have x plus 3. This is what I'm going to have. So if you put -4 while there's x here, you're going to have positive, because -4 squared, it will give you a positive, and then -4 plus 3, you get a negative. So -4 plus 3, you are getting a -1, so I'll have a negative there. So positive times negative, the answer will be what? Will be negative. So is a negative number greater than 0? The answer is no. So this region is completely removed. So we forget about this region. Let's try to test the region between -3 and 0. So we can get any number between -3 and 0. That is, we can even get a -1. So if you want, you can use this. You can be replacing the values of x in this expression to see if the number that you're going to get will either be negative or positive. Then you compare, you check if the statement will be true. But in this case, I'm using this one. So there's a greater than symbol there. So let's take any number between -3 and 0. You can even get -1. So when you put -1 there, the answer that you're going to get will be what? -1 squared, the answer will be a positive. Then when you put -1 where there's x here, -1 plus 3, the answer will be positive 2. So this will still be positive. So positive times positive, the answer is positive. So is a positive number greater than 0? Is a positive number greater than 0? The answer is yes. So this region is one of the regions that we need. Okay, let's also try to test this other region. We get any number greater than 0. We can even get a 1. So if we get a 1, we put it there. If we put 1 there, 1 squared, the answer will be positive 1. 1 squared, the answer will be positive. And then you put a positive 1 there. 1 plus 3, the answer will be 4, which is also positive. So positive times positive, the answer is positive. So is a positive number greater than So is a positive number greater than 0? The answer is yes. So even in this other region, we have discovered that the function is increasing. So the function is increasing in this region and also in this region. So the interval in which the function is increasing, we can just combine this and that. So how do you combine such intervals? We say the value of x for the increasing part is simply just going to be equal to -3, 0. Then union, you add two sets using the union symbol, 0, infinity. So these are the two regions, or or rather this is the interval in which the function is increasing. So now let us also try to look at the decreasing part. So for the decreasing part, we can also use the same expression, but we're just going to use we're just going to change the symbol. So we change the symbol. So we said for the decreasing part, the gradient should be less than 0. So this is the gradient function, it should be less than 0. So I think the only part where the function is less than 0 is this part here, because this is where we have a negative. So the only part which has a negative is the one that you get for the decreasing part. So the function decreases. So for decreasing, we say the function decreases. The function decreases in the region, or in the interval x is equal to from -infinity to what? To -3. So this is the region, rather the interval where the function decreases, and then this is the region where the function increases. So it's as simple as drinking water. This is how you solve such functions. This is how you solve such questions. Alright, so let's move on to this. So sometimes they can also ask you about the concavity. Concavity of a function. So they can ask you about that. It is also very simple. You solve it in a similar way that I've solved the increasing and decreasing function. So this will, for concavity of a function, you simply just have to tell whether the function is concave up, or concaving up, or it's concaving down. So it's just as simple as talking about decreasing and increasing functions. Alright, so let us look at C. So C says apply the first derivative test, or otherwise identify the relative extrema. So we apply the first derivative test and then identify the relative extrema. So these are the critical points that we have found after applying the first derivative. After finding the first derivative, these are the critical points that we found. Now, how do we identify the relative extrema? Or how do we find the minimum and the maximum value? Okay, in this case, they are not asking us to find the relative extrema. They're asking us to identify, meaning we just need to determine whether it's minimum or maximum. And I think here they were supposed to be apply the second derivative test, not first derivative test. So it was supposed to be applying the second derivative test. How do we apply that? So given the critical points as x is equal to, given the critical points as x is equal to 0 and x is equal to -3, we find the second derivative. So the first derivative was found to be 2x to the power 3 and then plus 6x to the power 2. So now we find the second derivative. We use the second derivative test to determine whether it's minimum or maximum. So when you find the second derivative, we're going to have 2 times 3 there, you're getting 6 squared, and then you have 12x. So now we have to identify whether it is minimum or it is maximum or it has a point of inflection. So how do we determine that? So we find f prime prime of, we first start with 0. So we replace 0 where there's x, we have 6, and then there's 0 there, and plus 12, then there's 0 there. So when you add these two, you're getting a 0. So when you have the second derivative being equal to 0, remember what I said? When the second derivative is equal to 0, point of inflection. And then when the second derivative is greater than 0, then it has a minimum. And then when the second derivative is less than 0, then it has a maximum value. Okay, so let us try to also test -3. So we say f prime prime of x of -3. So for this one, it's a point of inflection. Then this other one we test, we put -3 there, which will give us 9 times 6, which is 54. Then we also have 12 there, we put -3 where there's x. Then we say the answer here that we got was 18, if I remember, because we have -54 minus 36, that will give you 18. So 18 is greater than 0, so it has a minimum at this point. So it has a minimum at -3. Alright, so this is how you find such equations. This is how you solve such a question. Yeah, so make sure that you don't forget to subscribe to the channel, and if you have any questions, feel free to text me on any of these lines on the screen. And then if you have don't forget to click on the notification button so that you don't miss out the videos that I'll be posting. My name is Hamted. See you in the next tutorial video. Shalom shalom. And if you have any questions, if you have any questions about how you can start tuitions, feel free to contact me on my WhatsApp lines. See you in the next tutorial video.